Okay, so let's do a little bit more work with significant figures. Ultimately, the rule is that your answer can only be as accurate as your least accurate measurement. Okay, so let's write that down. The answer is only as accurate as your least accurate measurements. Okay, and that is the big rule whenever you're deciding how many significant figures to use. Here we see a number that has 2 significant figures, and this is a number that has 3 significant figures. When you write 10.0, that means that your scale was accurate to 0.1 of a gram if this was measuring 10 grams. So when you write it like 10.0, that's something very different than just 10. 10 means that, well, it was 10 grams, but it might have been 14, it might have been 8, we don't really know, and our scale just wasn't that accurate. But if you write it like this means that your instrument that you used was accurate to 1/10 of a gram. It means that it was not 9.9, it was not 10.4, it was exactly 10.0. So this one's 2 and this one's 3. This means we have to give an answer to 2 significant digits. So which of these has 2 significant digits? The point here, the decimal point, means that this 0 is significant, so that makes it 3 digits. This is out. This one has 2, so this looks promising. Let's rule out the others. This one has 1, 2, 3, 4 significant digits, because when you see the decimal point, that 0 that follows is going to be significant. This, oddly enough, so we can rule out this one, this only has 1 digit, but had we written the problem 14 times 10, that gives you 140, but to round off to 1 significant digit, which this is 1 significant digit, then really what we would want to write here is 100. So this would be the answer if we had left out that decimal point, but we didn't. So that's the answer there. It's different when you add. You don't just say, oh, this has 1 significant digit and you're done. In fact, this has 1 significant digit as well. Whenever you see these zeros here, these are not significant. And if it had zeros here, those would be. Okay, so when you add these together, your calculator would say 0.016. And the way you decide when you add is you look at your least accurate measurement. Say this is grams. This is accurate to 100th of a gram. This one is accurate to 1,000th of a gram. But because this is only accurate to 100th of a gram, it can't really say anything at all about the thousandths place. So what you would have to do is take your answer and round it off to the hundredths. Doesn't matter the number of significant digits here, that this is 1 and this is 1, but what you have to do is to round that off to the hundredths place, because this one is only accurate to hundredths. 0.02. So here is your answer for that one. Adding is actually a little bit more confusing than multiplying together, because multiplying, you just look at what your smallest number of significant digits is and you go with that. Okay, let's try a couple more where we're adding. Here we go. This is an interesting case because we have things written in exponential notation, which actually makes it a lot nicer. So here, if you put this into your calculator, you would get 4.60000 times 10 to the minus 4. That's what your calculator would say. But how do we decide what's really significant? We look at our least accurate measurement, and this is 10 to the minus 4 place, minus 5 to the minus 6th place. This is 10 to the minus 5, 10 to the minus 6. So that means that our answer here is accurate to 10 to the minus 6. So here we've got a 10 to the minus 4, 10 to the minus 5, 10 to the minus 6. These numbers right here are going to be significant where these zeros are not. Is this one of our choices? It looks like this is it right here. Let's try another one where we're adding together these kinds of numbers. This number is accurate only to the 10 to the minus 4 place. This one is accurate to the 10 to the minus 5. Put them in your calculator, you will get 4.6 times 10 to the minus 4. Probably your calculator will say 4.600000, but how do we decide how to round off? We go to our least accurate measurement. This is only accurate to a part in 10 to the minus, or a part in 10 to the 4. This is more accurate. This is parts in 10 to the minus 5. So what we have to do is to round this off only to the 10 to the minus 4. So this rounds off to 5 times 10 to the minus 4, which is indeed one of our choices here. So remember, the rule is your answer is accurate to your least accurate measurement. When you're adding, the way that works is to find which one it is. It's not that, oh, one of them is 2 significant digits and the other is 4 significant digits, so you just go with 2. That's not how adding works. Let's try another one. Put them in your calculator. 1.04, probably 000, times 10 to the minus 2. So here's your 10 to the minus 2 space, your 10 to the minus 3, your 10 to the minus 4 space. So this is what your calculator will say, but how do we decide what's really significant? What's really significant is going to be, this is your least accurate measurement. It's accurate out to 10 to the minus 2, 10 to the minus 3. So the only 2 spaces in your answer are going to be accurate out to 10 to the minus 3. So it doesn't even matter that you added the 4 times 10 to the minus 4 to this. Our answer here is 1.0 times 10 to the minus 2.